sorry. All right. So that one's pretty easy. All they wanted to show you is if these sides are congruent, then they're equidistant, right? We heard that word a lot yesterday. Sorry. So that one's pretty simple. Same thing in this one, but now they go in the opposite direction. So now again, if you determine that this is a perpendicular bisector, and they show these distances are congruent, then xy to yz has to be the same thing. Okay? Again, we can do this with algebra problems. So again, because they show that these are congruent and it's perpendicular, then my two quantities would be just set equal to each other. And then solve for x. Make sure you answer the question. So this one says find PQ, so after I find x, I got to put it back into the x and find the actual answer. Does it really matter which one that I put it in? No, because they are congruent. Right? Then we start looking at the circumcenter stuff. So here's again a good example of the circumcenter. Whenever we find all of the perpendicular bisectors, they are in red here. They meet at my circumcenter. And then from the distance from that back to each vertex, those blue lines on the inside of the triangle should all be congruent. Now again, this to me, if I looked at this, there's no way I would say that this line right here is the same distance as this line. By look. But because they tell me that it is a circumcenter, I know that that has to be true. So again, you got to go by what you know in your head, not necessarily what it looks like in the picture. You know, again, maybe it looked like that one to you. And so again, they just show you how to do the circumcenter. So, where could the circumcenter be in a triangle? You remember this part? So here's doing the circumcenter or trying to figure out where the circumcenter is. Again, if I'm going to do this, if they ask me to actually find it, the first thing that I'm going to look for is the midpoint on each side of my triangle. So again, I could just take a ruler and I could figure it out. Or you could use a protractor and you could do bisecting it. Okay? Most of you aren't going to go get a protractor. So you're going to use a ruler. But you got to find the midpoint. And then after you find the midpoint, you just got to make sure that you draw a right angle. Okay? And that's how they made all these. But remember, a circumcenter can be outside of the triangle, like in this example. It could be on the inside, or it could be right on the side. So don't forget that. So I think they're going to ask you to draw that. So then we go to angle bisectors. And again, if this is an angle bisector, this distance right here has to be the same. So if this is 5, this is 5. The same thing would be true for this part and this part. AC to AB would also be congruent. So we can do that on the opposite side. So this one, they're just showing you that, they're proving you that this distance is congruent to this distance. So this WY, or sorry, it should be YW because it's array, is an angle bisector. So when they ask you for WYZ, it's the same thing, but they could have also asked you for ZYX. And then I would do what with my 28? Double it, right? Or add them together. Okay? So just make sure that you really look at the 3 letters and know what they're asking you to find. Again, then I can do this with algebra problems. So as long as I realize that this is an angle bisector and these distances are perpendicular and they had congruent angles, then 4x minus 1 is equal to 3x plus 2. And again, make sure you answer the question. Here's the ones that get a little confusing. So it says find ST if S is the incenter of triangle MNP. Okay, so what does it mean? If they tell me it's an incenter, this is where you got to really be able to relate the vocabulary to the right part. So the incenter always goes with what? Angle bisectors. So I got to automatically think that each one of these segments right here, NR, PT, are all angle bisectors. So I can find this angle right here, I can find this angle right here, and then can I find angle P? Could I find angle P in this case? I know they don't ask you that, but can I find angle P in this case? Because why? And before, okay, so what is angle M in this case? 62, right? Because 31 and 31, because it gets split in half. And then up on top, I'd have to add 28 and 28, and then I'd take those two, add them together, and subtract it from 180. So that would be all of P, or they could have asked me, what is TPN, right? And then I would have taken that answer right there and just divided it by 2. Okay? How about what they actually asked me? Okay, is there a way for me to find ST? Well, first off, I got to find where ST is, right? So, what's true about ST, SU, and SR in this case? Okay, they all got a 90-degree symbol. What else? Okay, not perpendicular. They're not necessarily bisectors, but they're definitely perpendicular. But if this is an in-center, remember now, this distance right here, this ST, this SU, this SR, the ones that Merrick said had a box on them, they are all congruent. So essentially, I'm zoning in, when they ask me this question right here, I'm zoning in on this triangle right here. And if this is a right triangle and I have an 8 over here and a 10 over here, how can I find that distance right there? If I have two sides of a right triangle, what can I use? Pythagorean theorem, which is what? A squared plus B squared equals C squared. So in this case right here, I'm either looking for A or B, because my 10 has to be my what? The C squared, because it's diagonal or opposite of my box. So I would do 10 squared is equal to 8 squared plus B squared. So what's 100 minus 64? 36. So what is my answer? So even though I'm finding SU, it doesn't matter, because SU and ST, which they asked me, are the exact same. So I think it should be 6, right? Okay. Does everybody understand? We kind of seem like we're in a daze today. Does everybody understand what we're doing there? Some of us need to wake up quite a bit. So now they ask about an angle. So when you're talking about angles, just make sure that you zone in on the exact angle, and this is the kind of the one that we talked about. They said SPU. So we just got ahead of ourselves. We already answered that question by what Bo said. Everybody good with that? And then basically we're doing the same thing in the other ones. We could do these with vocabulary words also. Not vocabulary words, with algebra, meaning quantities. Okay, so the most important thing here is figuring out what goes with what, and then what that relationship is. So meaning, you have to be able to relate to a perpendicular bisector to a circumcenter, angle bisectors to an incenter, and then know what the relationships are in the problems with those types of things. Okay?